4.2, adding and subtracting decimals. There really isn't a lot of new stuff or new concepts with adding and subtracting decimals. All we're really going to end up doing is converting, or not converting, but we're just going to be lining up place values together, which means that the decimals should line up when we add and subtract these, which means also that we're going to be doing this in a more vertical type addition and subtraction, all right? Now, if we need to borrow, it's not a problem when we subtract, and if we need to carry values over, that's not a big problem. So just all the basic operation rules apply when operating with negatives, right? So if I were to add a negative, I could change it to subtraction if I'd like. Or you could say, well, how is it a bigger negative or positive number? And then that will tell you the value or the sign of your answer. And then just take the big number and subtract the little one. Okay. Now if we're subtracting negatives, we're just going to change that to addition, which hopefully will be helpful. But yeah, all the general rules that we went over in, what was it, module 1, I think, maybe it was module 2. It's the same thing, same stuff. So a problem like this one, I got 3 and 571 thousandths, and also 9 and 34 thousandths. So I can line these up, right? I got 3 and 571 thousandths. Now this is 9 and 34 thousandths. But again, I'm lining up the decimal and the place values. The 9 is in the ones place. The 3 is in the ones place, so I line those up. The 0 is in the tenths place, which is lined up with the 5 in the tenths place. The 3 is in the hundredths place value, which is in the same place value as the 7, so it's lined up vertically. Or you could say in columns, right? And then you got the 4, which is in the thousandths place value, lined up with the 1 in the thousandths place value. We just add these. So when I add them, I pretty much ignore the decimal, okay? Now the decimal, it's going to go in the same spot whether you like it or not. I mean, it's just going to drop straight down right there. And then it's just straight addition. So 1 plus 4 is 5. 7 plus 3 is 10, so I see how we carry the 1 there. So I got 1 and 5 and 0, which is 6, and 3 plus 9 is 12. So I got 12.605, or 12 and 605 thousandths. And yeah, we can double check this on the calculator. So 3.571 plus 9.034. And there it is. So that confirms the answer. Now the TI gave me the decimal. On the Casio, if you put it in, it may give you a fraction at first. Just push that same SD button that looks like. So yeah, the calculator confirms that we have done that correctly. So same idea with this one. I would only work with 2 values at a time, really, though. Just almost order of operations style, right? So I'd say, well, I'm going to combine my first 2 numbers farthest to the left. And what do we get? 0.081. And again, I'm lining up the place values together. So I got 2.221693. Now, just so we understand, if we have any empty place values for one of the numbers, we can replace them with zeros, like we are doing right here. Well, we're ready to add those together because we are looking at addition there. 0 plus 3 is 3. 0 plus 9 is 9. 0 plus 6 is 6. 1 plus 1 is 2. 8 plus 2 is 10. Carry the 1. 1 plus 0 plus 2 is 3. And 0 plus 2 is 2. Now, this is going to be plus, right, because we would, let's write the rest of that, plus this negative 11.14. Now, we could change this to subtraction, but I don't know that that may or may not be the best course of action. On this one, I would just look and see, well, I have a lot more negatives than I do positives on this one, so I know my answer to this one is going to be negative. And now I just take the big number, which is 11 and 14 hundredths, and I subtract the smaller number, 2 and some change. I think I wrote that out right. And again, I'm just using zeros here. Now this is subtraction, so I'm going to have to do some borrowing here, right? So I'm going to make that a 10, which means I'd have to borrow from here and here and here, all the way to the 4 to make that a 3. So 10 minus 3 is 7, 9 minus 9 is 0, 9 minus 6 is 3, 9 minus 2 is 7, 3 minus 0 is 3. That looks like I got to borrow from here as well. 11 minus 3 is 8. There's our decimal. 10 minus 2 is 8. And I just go back to my negative there. It is a negative answer. So let's write that in then. So it was negative 8. And what is that? 1, 2, 3, 837,307 millionths. There we go. And again, I'm just going to go to the calculator and check. This green number right here, I copied it down wrong. I put too many 2's there. Oh, what the heck? So how is that's going to change our answer? All right, let's try that again. 2.21693. So we don't even need that 0 on the end there. I'm just going to ignore that right there. Well, what do we get then? Let's see. Let's go back. It's the same ideas. This one was still addition, though. So 0 plus 3. Yeah, we get all these numbers here. Sorry, I made the mistake, so I'll kind of speed this up a little bit. And then again, would have to say we're going to add that negative 11.14. Negative. So 11.14 minus at 2.29793. I think I got enough place values now. Well, I wrote that correctly. So now I'm subtracting. Again, I'm just remembering that my answer is negative. And what do we get? So I had to borrow here on these ones. All right, so 8 and 84,207 hundred thousandths. But again, I just need to remember that's a negative. 84207. All right, so let's go to the calculator and check this now that I have copied it down right there. So even after typing it into the calculator wrong, we fixed it. And now our answers do match. So that works. All right, well, what do we do about a problem like this one? Well, since we're only dealing with 2 terms on this one, the negative is bigger than the positive. So negative 7, even if I was just to look at the ones place values, negative 7 is bigger than positive 5. So whatever I get out of this, I know is going to be negative. Well, then I can take the big number, which would be 7.2, and subtract the smaller number, 5.8. And what do I get? Well, I have to borrow, right? The decimal goes in the same spot. But I'm going to have to borrow from the 7 to make that a 6. 12 minus 8 is 4. 6 minus 5 is 1. So it'll be negative 1 and 4/10. But again, I just want to check on the calculator. So negative 7.2 plus 5.8. Yeah, the calculator confirmed that we did that correct. So now I would feel more comfortable boxing that in or putting it into the homework. All right, why don't you guys try this one? We'll give you 30 seconds. See if you can do this one, all right? 30 seconds, go. All right, let's check our work here. So 0.3 minus 7.9. Now we're taking away more than we have, right? So if we were to do this by hand, maybe you've changed this to 0.3 plus negative 7.9. And I don't know if that makes it more clear, but hopefully we understand that the answer is going to be negative one way or the other, right? So if we look at the one at the top there, we're taking away more than we have, which means we have to end up in the negatives. If we change it to an addition problem, we're adding more negatives than what we started with, which is what makes it negative. But in any case, with the addition problem, we could say, well, we're going to take the big number now that we know that the answer is negative. So 7 and 9/10, and just subtract the smaller number, which is 3/10. Well, 9 minus 3 is 6, and 7 minus 0 is 7, so it's negative 7.6. But again, we'll check on the calculator. Got that typed in already, and it shows that the answer is negative 7.6, assuming I typed it in correctly, and we're good. All right, with subtraction like this one, negative 6 and 1/10 minus 8 and 8/10. Again, if we change this to addition problem, so negative 6 and 1/10 plus negative 8 and 8/10, we can see we're just adding negatives together, which means that we're going to keep the sign on this one as negative, but we're going to take the two values, 6.1, and add them together. So the 8 and 8/10 with the 6 and 1/10. So adding these together is 1 plus 8 is 9. 6 plus 8 is 14. But again, we know it's negative, so it's negative 14 and 9/10. But again, I'm just going to check on the calculator. Negative 6.1 minus 8.8. And yeah, that checks off. So I'll box it in. All right, negative 3 and 7/10 minus negative 4 and 5/10. See if you guys can do this one another 30 seconds, all right? 30 seconds, go. So let's go over this one. Now, I would change that to a plus sign myself, because minus negative is the same thing as addition. Now that it is an addition problem, I see that I have more positives than negatives, so I know my answer is going to be a positive. And then, since the signs are opposite, I can take 4 and 5/10 and subtract 3 and 7/10. So I need to borrow the 5 and make that a 15. 15 minus 7 is 8. 3 minus 3 now is 0. So the final answer we get is 0.8, or just 8/10. But on the calculator, let's just double check, and it confirms that we've done that correct. All right, here we go. Kyle has $24.95. You guys knew this money stuff was coming up, right, with decimals. And purchases an item for $14.12. How much money does he have left over? Yeah, this is another good one, you guys. Try this one. 30 seconds, go. All right, here we go. So Kyle has $24.95. That's what he's starting with. But then he's going to purchase an item for $14.12, which means that from the $24.95, he's going to remove $14.12. So yeah, this is a subtraction problem. And 5 minus 2, that'd be 3. 9 minus 1 is 8. 4 minus 4 is 0. 2 minus 1 is 1. So it looks like Kyle will have $10.83. Now, remember on the homework, these are usually labeled for you guys already. But again, on future tests or future classes that you guys take, if you need to take them on paper, just make sure you label these. Whenever you see a word problem, always look to label it. And this one was asking how much money does he have left over, so I've labeled it with $, $10.83.